so far we talked about basic control structures of programs, we analyzed the complexity of control structures of programs. But what we have learned so far, we have learned about some basic data types, integer, char, float and so on in C. Okay. Now, problem is these are generally good enough for most of the computation that most people do, but sometimes maybe you would like to take these basic data types and make more useful data types which are useful for your work. Like so what you do is, for example, I can write something like a record or a structure as it is called. I am not writing in C syntax over here, and let us say I want to make a student record. I will say name, student name, which is of a character array, okay, array let us say 100 characters of char. Then I might say student roll number, which can again be an array of let us say 10 characters. This is basically your ID. Then I may like to say students mark, let us say this is with respect to a particular course, course name. In IIT we have 6 characters for courses. So, let us say I have array of 6 of char, and let us say course marks, assignment 1, assignment 2, it is of type real or float, and let us say quiz 1, quiz 2, end sem is of type real, and then you have a total, okay, which is also of type real. So, this is something which you have seen, which you might have seen in your in the basic C course that you already did, that you can put a set of assorted elements together. Here we have character and total may be of type integer, let us say. So, what do you have here? Roll number, name which is of type character, string of characters, student roll number which is again a string of characters, course name which is an array of characters, again a string of characters, assignment 1, assignment 2 which is of type real, quiz 1, quiz 2, end sem which is again of type real, and total is integer based on which a grade is given. Let us say we also have a grade which is of type character. Okay. So, what I have tried to do is we create a student record with all the information together. We are doing a kind of an organization, if you see. What is the organization that you are doing? For a particular student's roll number, we keep track of the name, we have the course number here, the assignments, the quizzes that he or she has taken, total that he has got in this particular course. I am doing it for a particular course, let us say, and a grade that he has obtained on this course. So, this is one type of data organization. So, what have we done? We take the basic building blocks like the integer, character, float and so on, or real for that matter, put them together and make one data structure. And what we want to do is, when I am looking at a particular student's information, the entire record is pulled out, so that I can look at his assignment marks, quiz marks, end sem and so on. This is one way of organizing. So, this is called a data structure. Okay. Next, what we are going to do is, this is one part of the problem where we take these basic building blocks like int, char and float, put them together and make a record, and then when you want to pull out a particular person's item, for example, I might have an array of, let me say this is record of type student or whatever, and then I might have an array let us say in my classes of 1 to 65 of students. Okay. So, it is an array of this record of students. Then to access a particular element in this, all that I have to do is look at, let us say of type student, let me call it studar or something like this. This is the type and this is the actual allocation. So, I look at studar of let us say 25, and it will give me the 25th record in this particular array, and I can access all the elements. It's a very nice idea, putting all assorted elements together, making a data structure out of it. Today what we are going to talk about is little bit higher than that. That is what a data structure is all about. We are going to talk about what are called abstract data types, and what we are going to do is, now what we are going to do in this particular part of the course is that not only are we going to do an organization like this, but we are also going to define a set of operations that can be performed on this data structure. So, first thing what did we do? We organize the elements in a particular form, and then we are going to define a set of operations. For example, you know what are the operations that you can perform on int? If you are looking at C, for example, you can do addition, plus, minus, division, percent. Similarly, if you are looking at float, you can do plus, minus, slash, and there are other operations, but this is the minimal set of operations, and multiplication, right. And if you look at character, for example, you can do a plus where it kind of concatenates, and then you have the strn, strcat, strcomp, and various operations that can be performed on character strings, character slash strings, let us say. You have a set of operations that have been defined. Okay. So, now for example, when you look at these operations plus, minus, slash and percent, if you look at these operations here, which are also used for float, and remember here you can also use a star, okay, percent remainder will give you the, so basically what the compiler knows, or what the computer knows, for example, is that when you are performing plus and minus, if I say int x and y, and I say int z, and I say z is equal to x plus y, it automatically knows that the plus operation is performed on operands which are of type integer. Similarly, if I say float uv and float w, and I write w is equal to u plus b, clearly it knows that u and v here are of type float, and the result is to be stored in w, which is also of type float. Notice that we are using the same operation, plus here and plus here also. So, what we want to do is that we want to add more functionality. I want to add my own data types, just like you had integer and float here. Can we add our own data types and give new meaning to these operations? For example, suppose I wanted to do, let us say I want to look at matrix multiplication. Okay. So, a matrix of size 2 matrices, let me say M1 and M2. Then I want to define a new matrix, let us say I would like to say something like this, matrix M1, M2, and I would like to say matrix M3, which is the output, and I would like to say M3 is equal to M1 plus M2, which is the usual. What is the meaning here now? The meaning here is that M3 is the result of the sum of the 2 matrices, and similarly I may like to say M3 is equal to M1 minus M2, M3 is equal to M1 transpose or something like that, transpose of M1, M1 dot, let me say M1 transpose. Okay. I would like to say transpose of M1. Okay. And similarly, I may like to say M3 is equal to inverse of M1, and so on. I may like to do a whole lot of operations like this. What have we done here? I would like you to focus on these 2 operations. What is the difference here? Here we saw that plus and minus are operating with respect to integer. Here float, plus and minus are operating with respect to float here. Here plus is operating with respect to character here, and here For example, what are we doing here now? Here you are saying now plus and minus are going to operate with respect to matrices. So, basically what we are trying is, can we somehow generalize this whole idea of what is an operator. Okay. We know that if you look at the string cat and string compare functions, what do? They are essentially doing some operations on a pair of strings. A pair of strings are given as argument to string cat and it will concatenate the two of them and give you the result, which is a concatenated string. So, one way of looking at it is, it's a function, all right, but the function or the procedure is like generalizing what we call the notion of an operator. I have a comparison operation to be performed and we are having a function for it or a procedure. So, already we have procedures which kind of generalize this notion of what an operator should do. So, now instead of using these operators plus, minus, multiplication, division, can we have user defined operations. Similarly, the data on which the procedure should operate, like I can give my own organization of the data. Okay. Can I also have a whole lot of user defined operators. So, what is happening is, here if I look at it, matrix M1, M2, M3, so I have to specify how this matrix is actually represented. It has to be in a particular representation, which is a 2-dimensional array perhaps, should be the representation of the matrix, but the operations are actually here being performed on arrays, and that is internally defined by the user defined functions that we have. So, what we want to do is, just as you have procedures that can be used to encapsulate functionality, we can define what are called abstract data types that can be used to encapsulate data types. I have already given these two examples. Another example is, if I want to, that in C you have only integer, float and char, you do not have complexes of the find. For example, you have a number a plus ib, and can I represent something like C of 0.5 comma 0.5, complex C, my type here 0.5 comma 0.5, and can I make the operations of addition, subtraction and division to be mean something different in this particular context. So, basically what we are talking about, we are going a little bit higher level here. We have a mathematical model and an informal algorithm. What do I mean by that? When I say matrix M1 and M2, then when I am talking about addition, I have an informal algorithm which tells me how M1 and M2 should be added. When I mean informal here, I am more talking about something like when you write in English kind of statements, what this informal algorithm to add to matrices is. Then what we do is, from there we go a little bit more formal, convert this to what is called an abstract data type. For example, in the matrix you know what the meaning of it, and then the abstract data type is closer to the higher level language. Then you write a pseudo language program. What do I mean by a pseudo language program here? You are writing something like an algorithm in a pseudo language program, such that if I translate it to a particular higher level language, it should work exactly. And what is the correspondence with this? This abstract data type is represented by a data structure, and then the operations that are performed on the data structure are written in a higher level language program. Okay. So, we start with a mathematical model, informal algorithm, like for example, in sets, right? How do you say, what is your mathematical model? You will say S1 is of this form A, B, C, D, E, and S2 is of this form C plus C comma D comma E, and if I say S1 union S2 is nothing but A comma. So, this is what we mean by A, B, C, D and E is what you will get, whereas if I do S1 intersection S2, it is going to give me C and D. So, what have I done here? I have definition of the sets, a mathematical model for representing sets, and from the elements that I use in the set, I know what the type is. Then I am defining an operation called union, I am defining an operation called intersection, which operates on these sets. That is what we mean by a mathematical model and an informal algorithm. Then abstract data type gets closer to the computer. So, now then what do we have to do? What are the elements in this particular set? What is the type of the elements in the set? For example, suppose I had 1, 2, 3, 4, the element type would be of type integer, these are elements of type character, and then how do I represent a set? I may require a special type of data organization just like we talked about over there, and then these operations which operate on the sets, now I have to write functions which will take whatever data organization I have and operate on them and give the result. Okay. Then what we do is finally we say, okay, I have a higher level language, how do I translate this whole thing into the higher level language? So I convert it to a real data structure like this kind of a data structure over here, and then I define a set of operations on this. So finally abstract data type, when you look at it, it's like it's going to look something like this. So we have, let me call it an ADT for matrix. Let's look at matrix or set. Let's do ADT set. Okay. So I have here some representation of the set. How should this set be stored? Should it be stored in an array or a linked list or whatever? Then I have a set of operations which are performed on the set, like union, intersection. For example, it will take union, intersection, complement, and so on. All right. So these operations operate on this data, and what we normally do is the data is completely, the representation of the data is completely hidden from the user. The operations are known, and these operations can take arguments. What arguments these operations take? For example, I may say here it takes as argument set S1 and set S2, and intersection is also taking the same argument. Complement again, because you are subtracting, let us say, from one to the other, set S1 and set S2. Okay. So it basically takes as argument sets, and then there are operations that are performed in the set. So obviously what is it going to do? It is going to operate on the data, the way the data is represented. Each one of these functions is going to hide the whole information here, and it is going to operate on the way the data has been represented, and finally the result is going to be the union of these sets. And what will this be? This will again be a type set. This will also be a type set. This will also be a type set. So basically these are things that you can do with what are called abstract data types. Okay, you have a representation here, some representation using whatever structures are available in the programming language, integer, character, float. For example, I have to specify, of course, is a set of characters, is a set of integers, is a set of some other kind of objects. That information is given here, and then you decide whether you want to use, because set is consisting of a set of items, we are left with no choice but to say some array or a linked list representation, and then we perform a set of operations. So now what do these operations do? The operations will look at this representation and perform the operation of union, intersection and complement, like we said in the mathematical model over here. So we will stop here for now, and we will continue with an example on complex in the next class. Thank you.